So as Adrian pointed out, we can use our kinetic energy equation, 1/2 times mass times velocity again. And let's do capitals. Makes it a little bit easier to see. So when we put that in our calculators, we put in 0.5. And for the mass, you want to divide by 1,000. So you can either put in 650 and divide by 1,000 at the end, or you can just divide by 1,000 directly, which is what I like to do. And then you do the velocity twice. And you go ahead and put that in your calculators. Milo, that's enough. I know you're good at physics. You don't have to tell everyone the answers. Okay, so we put this in our calculators. And indeed, as Adrian said, you get 2.9 units of energy. 2.925. Now, the last two steps is always rounding and units. And again, Adrian got this one right. So he rounded it to two significant figures because we have a 3.0 and both the 6 and 5 are significant and the units are still joules. If in doubt, if you see the E for energy, it's probably going to be joules. And that was the whole point of dividing by 1,000 to make sure we get to our standard units of energy. Okay, so that's part one. Seems like everyone understood that. The one thing to note is make sure you're very careful with the units. So some of us are still not being so careful with the unit. So as soon as you see 650 grams, that's telling you two things. That's telling you that the answer should be 2 sig figs, and we need to divide by 1,000 to get our standard units. So as soon as you see 650 grams, that's telling you a lot of information. It's not just a number. You have to learn to pay attention to the units as well. Okay, any questions for part one? If no, make sure you're active in the chat saying no, so I know I can move on. Any questions for part one? No. Okay, excellent. So let's keep going. So part two is we have Hill energy or gravitational potential energy from last time becoming kinetic energy. Okay, so potential energy is becoming kinetic energy. And there will be a lot of questions like this on the test where you're going to have to connect the different types of energy we talked about. So we talked about last time the potential energy due to gravity changing and how to find that. So if we know that we're going down a hill, then we know that's the type of energy we have, and that's why we're going to gain some speed. Now, the important thing here is it is without friction. So we know there's nothing else going on. It's just purely potential energy turning into kinetic energy. So we can use this equation here. So the first thing that we need to know is how to set it up. Again, to reiterate, how we set this up is we see that we have velocity. So we know that that is going to be what type of energy. Put it in the chat. As soon as you see the word velocity, what type of energy are we going to be getting? Kinetic energy. Yeah, if you're saying kinetic energy, put it in the chat. Yeah, as soon as you say kinetic energy, as soon as you see velocity, we know that this is going to have something to do with kinetic energy, okay? And in general, for these type of problems, you're going to say this. You're going to say what we start with, and I'll type this so it looks really nice. Oh, that was terrible. Okay, I'll type this. So, and these type of problems that are a little bit more trickier, you're going to say the energy at the start is going to be equal to the energy, the type of energy we want. So energy at the start is the energy we want. We also write that as total energy at the start is equal to total energy anytime. This is our conservation equation. So this is how we start these problems. We look at the type of energy we want, which is kinetic energy, and the type of energy we start with, which is, in this case, the source of energy. The source of energy is that potential energy due to gravity. And there will be several of these type of problems. Okay, so now here's the next cool thing. A lot of us were concerned about not knowing the mass. But if you just follow the steps I'm teaching you, actually what you find out is the mass doesn't matter. Very interesting. Notice there's mass on both sides of these equations. So in fact, the change of velocity for an object is independent of its mass. What can we do mathematically to both sides of this equation? Again, put it in the chat if you know. Control. I don't know what that turned red. Yeah, now we're starting to get it. On both sides of the equation, we can divide by mass. And this is something you're going to see time and time again. Potential energy due to gravity and kinetic energy, both of them have to do with mass. So one turning to the other is actually independent of mass. A larger object will have more potential energy, but it will also get more kinetic energy. So it's actually independent of the mass. You don't need the mass to solve this problem. That's very important. Okay, let's keep going. We got rid of the mass. That's nice. So we just have GH, well, we have that, is equal to 0.5 times velocity squared. Well, that's what we want to know. So just by following this method I taught you, total energy at the start is total energy anytime, at the time we want, we're able to work through this problem and we actually have enough information. So we can continue to simplify. What should I do with this 0.5? How do we get rid of a 0.5? Go ahead and put in the chat if you know. If you have 0.5x and you want x, what should you do to that 0.5? Yeah, everyone's getting it now. Multiply both sides by 2. So we get 2 times gravity times our change of height is equal to velocity squared. Now, lastly but not leastly, you got to take a square root. That's the only way to get rid of a square, is to get a square root. And so we end up with the velocity is plus or minus. And I got to give a shout out to Emily because she was the only one to include this plus or minus. And in this case, it's definitely going to be minus. Definitely going to be minus because we're going downhill. So it is going to be not a positive velocity. It's going to be a negative velocity. It's going to be a velocity downward. So you could either say a positive number downward, which indicates the direction, or you can say negative. That's another way in physics we indicate things are going downward. So it is the square root of 2 times gravity times the height. And this is an excellent equation you want to box right in your notes. Make sure you have for Thursday, because on Thursday, you're going to have the opportunity to use this equation. That's a big hint for you guys. Big hint is this is a very important equation that relates potential energy due to gravity to kinetic energy. There will be one of these on Thursday. So we'll go ahead and box this. This is an important equation for you to use. Now make sure you add a note. You don't just write it down and don't add a note. This equation is for this type of problem. So don't use it for another problem. This is important equation, just like this equation or this equation. All of these are essential equations that will be on our test. And we've been working with them for about a month now, so a lot of you are getting very comfortable with them. Okay, now we just plug in. And it's not letting me type. Oh, there we go. Okay, so we plug in, the velocity is going to be minus the square root of 2 times 9.8 times 3. And the square root of that is 7 point something. Let's actually put that in the calculator and see what it says. I'm thinking it should be 7 point something. Yeah, 7.7. And this makes a lot of sense. Negative 7.7 meters per second. Okay, this makes a lot of sense. We're going down 3 meters. And that potential energy is turning into kinetic energy. Thank you for those of you who tried it. For those of you who still aren't certain, make sure you view this video and use it to study. So we're going to use this same equation that I put in brown here. This is our equation for this situation, for turning potential energy into kinetic energy when we don't have friction or any other factor. So it is the negative square root of 2gh. And yeah, now we can plug in our numbers. So the negative square root of 2 times gravity, which, as we said before, is 9.8. And this time we have double the height. And importantly, we notice that this is a square root. So even though we're doubling how high we're going down, it's actually not going to increase by 2. It's going to increase by the square root of 2. That's an important difference. Don't just double the velocity and think you're going to get the correct answer. It's not going to increase by 2. It's going to increase by the square root of 2. And if you don't know the square root of 2 off the top of your head, we can put that in our calculators. And we'll get negative 10.84. And now lastly but not leastly, as always, we need to check our units and our rounding. We want to have 2 significant figures. So we're going downward, so it's a negative, and 11 for 2 sig figs, and we round it to 2 sig figs, 11 meters per second. So the answer is, the velocity is negative 11 meters per second. We'll keep working on these, but make sure you view this video as you study. Have a good day, everyone.